So hello everyone, this session today I'm going to talk about is defensive programming. My name is Vance Villanueva. I'm a technical services engineer in 40 Inc. since 2013. Last night someone asked me about defensive programming. And they were saying, is defensive programming actually fighting against your actual deployed application? So you mean like a customer is trying to complain about it and you're just trying to defend yourself? No, that's not actually what this is. It's actually more about going back to the basics. It's not my intention to break your coding styles or techniques that you have actually done for the years, but it's to give you some information that is obvious or not so obvious when coding in 40. The information that I present to you today can give you options on how to approach 40 code in general. So as developers, we take the big assumption in writing our code from knowing exactly what the code does and how the functionality works. But what really gets us is the runtime errors, hangs, and crashes. 40 in common, we do get these kind of runtime errors in development, and I'm going to show you some examples, like an array range check error, where arrays can actually go out of bounds, accessing a parameter that does not exist, bad usage of a pointer when we're trying to actually access different types, and believe it or not, some sort of calculation trying to divide by 0. These are some of these runtime errors that we actually can run into. So here's some examples. Array range check, invalid character reference, not enough space in memory, an actual hang, 40 has stopped working. So these are just a couple, just to give you an idea. That at this point you can do your best to catch these errors through your testing phase, through all of these processes that you're trying to mitigate all these issues. But there's things that are really out of your control, and you get to a point where you do your best. I mean, you really do your best, but with user error, with corrupted data, there might be situations where you cannot handle those situations. So, for instance, when customers they see a screen like this, they get frustrated, and they're not sure what they could do. So they might just cancel the application and then restart it, or they just pretty much complain. But as developers, you get more stressed out, and you're trying to figure out this kind of nightmare, and you don't get sleep, and you just want to get things going. And at times it just gets difficult when you try to debug these kind of issues, either at the site or when you kind of get the description from your actual customers. So many times you guys might have to go into interpreted mode and try to find out where exactly that part of the code is actually having this issue. And many times you can't figure this one out because you just see an error that maybe 40 doesn't really show properly, and you try to figure this one out. So how do we deal with reducing and mitigating these type of errors? So we use defensive programming. It's an approach just to take a step back of your code and reassess 40's code usage to a proper practice that can prevent these errors. Although these techniques will not be 100% foolproof to actually defend everything, but we're trying to get your state of mind of trying to think about your code a little bit more. Take, for instance, code that's been written years ago, and you look at documentation, and you would do this particular code, and somehow you wing it, and the code seems to work with functionalities that are not actually documented in the documentation. So through the years, you've been using this code, and then at some given point of time, it fails, and then you don't understand why, but it worked before. Now, the developers in the past may have coded it a certain way, and it gets cleaned up, and at some given point of time, it's supposed to work per documentation spec. And this is where, if you don't understand the documentation to a certain point of using these commands and you're just taking it as it is, you could get into these kind of issues. So this is more of a basics of understanding, being preventive of what you're actually coding. So in this session, I will cover 4 areas of defensive programming that I would like to focus on. There may be other areas that you may think or after during this session. But I'd like to get you in this state of mind of defensive programming right now. So the first is 40 constants. 40 constants are used everywhere in 40. I'll show you some examples of this importance of using 40 constants. The second is OK variable. There are many 40 commands that have a status of using these commands. And the 40 OK variable is just a good prevention for unnecessary code and much more things. The third thing is checking before access. I mean, believe it or not, we make the assumption that when we write this 40 code, we think it's supposed to work a certain way. And this way, we've done it for many years, but there is just this small chance that you never think of this certain circumstance. And I'll show you something, for example, of could be possible examples. And the last is dispose of occupied memory. There are some commands out there that you may just use it a certain number of times, and maybe your memory might just creep up, and before you know it, you might have a runtime error, or you might have a crash and you don't understand. So you may have used it and it worked in your testing phase, and at some given point of time it just causes a problem, and you're kind of confused how that works. So this will just try to get you in the state of mind of thinking of certain commands, and there might be other commands, but I just want to give you an example. So let's start off with 40 constants. So why do we use 40 constants in defensive programming? First, it's easy to maintain between versions. Constants are created in 40, so it's easier to read as opposed to putting numeric values. Another is that the value could change, but the reference does not. So if you have a constant and it has a text of a certain value that you see, the reference coming back to it in 4D won't change. So you might have something that might say carriage return, and one day we'll just shrink it up to like CR. We could do that change, but the reference in the background will still be the same. And the last thing is just easier to work with cross platforms. A lot of you guys are probably deploying in Mac and Windows, and you may or may not notice that there's certain things like files to access that you might be doing a lot of work. I mean, like writing hard-coded paths, and maybe you don't need to do that, so just want to go over those with you. So let's take a look at some examples. So let's say that we have a folder and we want to access the file.txt. Well, in the Mac, and Mac uses the colon and the Windows uses the backslash. A simpler way to do this and to reduce, we just need to use the folder separator. So the path with this would just be the constant folder separator. Also, this particular command is good even to determine what operating system you're using. Are you using Mac or Windows? You can use the folder separator to determine, like, if I'm using the colon, I know that I'm on a Mac. So you can pretty much reduce your coding. The second example I like to go over is the database location. So you could go back to the root of the database and just hard code the actual database location, and assume that this will work for you through time. But you can actually just use the get40 folder and use the constant database folder, and you can go straight to that location and then go from that point wherever your structure is located at. Now let's take, for example, if we have some text data and we're using these like character return and line feed, and we use the char command, 13 and 10, which is the ASCII equivalent. I mean, we could use these down the road, but let's say that you are going to have other people look at your code one day. We can actually just use the constants just to make it easier for someone to look at the code. So these are just examples I want to give to you about 40 constants. There are a lot of constants everywhere with every, for 40 Write Pro or any kind of parts of 40 commands, but I'm just going to give you an example of these. The next section I'd like to go over is the OK variable. So why do we use OK variable? Well, it verifies the command execution when it's successful. Many times we may not know that a certain command might have a response back to it. We could just take for granted that we take the command, we know it's going to work, and it's just going to work the way it's supposed to go. So this OK variable can at least give us some sort of verification that we did this right. And then, of course, if we know it's right, then we could prevent any unnecessary execution of code. There's a lot of code that we could just really omit if the command doesn't work. And it's also a fail-safe under certain conditions. So let's just take some examples of this OK variable. But before that, if you look in documentation like SQL login, on the right side you will see in properties that there is an icon that says OK. And when you see that OK, somewhere in the bottom of the documentation you can actually look at the status. And this is a very good thing to really check on certain commands. So let's take a look at some examples. For instance, the SQL login command that I just showed earlier. So if we were going to try to do some ODB connection, and this connection, we're assuming that, hey, this person is going to log in and it's just going to work. And then we just go ahead and we do the begin SQL and end SQL command, and that should be good enough. But what if the actual login failed? We're still going to continue going down that path of execution, and we will get an error if we try to run that SQL and end SQL code. So to mitigate this, we just check the OK variable. Now, how about if we work with XML? In this example, we are taking the location of that XML, and we use DOM-parse XML source to actually put this into memory. Now, let's say that that second line worked. Then we can go ahead and we can actually continue with the next line. But in XML codes, you can actually check the OK variable. So it's a good practice to make sure that if you are checking these variables on DOM XML commands, the OK variable is a very useful tool. Now, I want to go to the next section that has to do with check before access. And why would we want to check before access in general? First is, the improper use of this command can cause an error. We might take an assumption that we know this command very well. We've used it so many times. And there might be this special case where using that command just had that unrealistic input, a different type, for instance. So I'm going to show you an example of that. How about when accessing data that's not even present? That can happen. You run this command and you don't check the data and you try to put something. This can happen. Not knowing the data types. You could be trying to access a particular pointer, for instance, and that pointer might be a type that you expect it to be, but it doesn't happen, and you could get an error. And of course, it's not safety checks. So let's take a look at an example of this one where we're using the SQL code to insert into this array like the table names. Now let's take, for instance, if we had a blank database and we had no tables and we try to run this code and we try to access the first part of that array. Well, if there's nothing in that array, we're going to get like an array out of bounds. error. So the way to practice for that, and here's the example of the runtime error that could happen, we can just check the size of the array. Another example I would like to go over is like text, accessing certain areas of the text. So in this my test, we have 4 characters. Now these 4 characters, okay, we kind of know that this is just an example, but let's assume that we always wanted to hit a certain location. And in this case, we're trying to hit the 5th location of this particular string. What can actually happen is we can get an invalid character reference. And this is a simple example. I mean, we could take, for instance, if you're getting data via serial, you know, like you're expecting 255 characters, or you're trying to query something and that you expect a certain number, this can actually happen. So for this, we could just use the length command to actually get the size before we actually run to this code. Now I'd like to go over objects, 40 objects. And the simple command that you can use in the beginning is using obget. Now in this example, we are trying to access something that we assume to be a long int. Now if we try to assume this to be a long int, and let's say it was another type, we could get an error like this, attempting to retype by using a pointer. So what we can do defensively is to check if the property is available. And if it is available, then let's make sure that we could check what we're expecting. We're expecting a real, a long int, so let's check it with obget type and then do the execution. This may be really simple, but I'm just trying to get you in that state of mind that like you may be getting objects from a JSON set of data and you're expecting something, and somehow the data wasn't fit to the spec that maybe you guys have designed, and this could happen. So I'm just trying to give you an idea that this is something to think about. Now, in the previous example, previous section, I talked about the OK variable. Now, the OK variable is good to check the status of a particular command. But with the JSON parse, the OK variable is not possible. So in this example with the JSON parse, we are trying to take the text of this object and then make it a 40 object in return. And if you can see in the example, the right curly brace is not completing this object. So what can happen if you ran this command? You can actually get this error of like the JSON's malformed. Now, you may do this a lot in your code, and this is one of these practices where you can actually check this command by using the onError call, where you can actually put a method just to prevent something like this, where you could have a malformed data coming in, and depending on JSON parse, and you could just prevent yourself from getting a runtime error from doing that. The next example I'd like to go over is the pointer, passing in a pointer in a method. So in this example, we are just taking in a pointer, and we are just assuming it's going to be a certain type. To protect ourselves, we can check the type using the type command and go with what we're expecting to have. In this example, we're looking for an object array, and we want to proceed from there. But the type command is something that's very powerful, that we can determine the actual pointer type. Now I want to go to an example with list box. Now with a list box, in this example, in an array-based list box, there's 3 items, and a user may click on a certain area that's not part of that list. And if you code it in a double click, you can actually try to access that part of the array. Now the thing is, you can actually use a command like listbox get selection by the cell, I mean, you can pretty much do that, but I'm just trying to show an example that the functionality of getting the actual location of the array, we can click and get this part. So if you click in that area, the list box will actually be 0 and the column will be 0, so you'll be trying to access that location. What you could do in this scenario is that you could check if the list box is greater than 0 before accessing the array. Now how about when you have a method and you're passing in parameters? In this example, we have a long int that's $1 and $2 to give a result in $0. Now, but what if we wanted to just put only one parameter in there, and it would go to $1, and if we try to add to something that is nothing, we'll get an error. So to protect ourselves, we can use the count parameters command to make sure and to ensure that we can actually make sure that we have these number of parameters. Because in the actual code, you can put so many parameters in there, and 40 will take it. It's very forgiving to put as many parameters in there. But count parameters can protect you from actually any kind of data that's that needs to be there, that number. A common command that's used is the open document. And if you took this location and you depend on this location all the time, it may work. But what if this location changed, or some other hard-coded place that you thought was supposed to be there? Well, you could get an error like this where the document could not be opened. To defensively be aware and to program with this one, you can actually use the test path name command and check if it is a document, and from there you can go and proceed and do what you need to do with the open document command. Now I'd like to go over components. So in practice, if you put a component in the components folder next to your structure, you will get something that is tokenized. Now, what if you have no components in there and you try to call that command? Well, it's not tokenized at all. And the example here is just to give you an understanding that this is about tokenizing. And when you deploy an application, you want to make sure that your component method works before you deploy it, and you have the components in your components folder. But what if technology comes around and you have new features and you don't want to deploy? And I mean, you don't want to recompile your database and do this deployment. You can use a command like execute method to actually put in text of the command. And an example like this would be like the information component that we, as tech support, asked everyone to use if there's issues or just to get a status of your database. But putting this command alone and assuming that we did have the components in the components folder, we could get an error if that we thought it was there and the project method was not found. So what we can do is we could just use the component list to check if the component is actually there, and then find it in an array and execute the method. Now I'd like to go over two commands, that are very common: delay process and resume process. These actual processes can access 40 internal processes. Now, if we take, for example, the count task command, which can pretty much list all the 40 commands that's running in 4E, we can actually use the resume process and delay process. And not knowing that you are using it could cause clients to not be able to log off 40 server and 40 server might not be able to shut down because there's some running processes going on. And at that point, it's uncontrollable, and you probably don't understand why. And this is something I'd like to point out, because we're getting a lot of cases where customers cannot log off, or the 40 server can't shut down. And these are one of the things that I see, that old practices of just count task, of actually running resume process and delay process, you might not know that you're really accessing 40 processes. So what you can do is you could use the process properties command and checking the origin. Now with the origin, if it's greater than 0, you use new process or any kind of processes that you created programmatically. Anything that's less than that is 40 internal processes. So a safe way to do it, for instance, for the resume process, is to check the state. If it's paused, then go ahead and do it. If it's delayed, then go ahead and do the delay process. But you do check that you're using your processes, not 40 internal processes. The next section I'd like to go over is the disposed occupied memory. So why do we have to be defensive about occupied memory? Well, it prevents out-of-memory crashes. A code used may not be obvious, where it uses a lot of memory, and then eventually it just crashes. Another, this would prevent memory leaks. Some code might be using commands, but it might not be freed by 4D. I mean, we're thinking that 4D can actually be the garbage collector and clear up all memory, but there are certain cases where if you're not aware of it, you can get a memory leak. And also, we could demonstrate the reuse of memory. That 4D can reuse memory, but could be an issue if you don't clear properly. You could be accessing something that might not be there anymore. So that's an example. So let's take example of SVG new. So we want to take this instance, and we want to use the command svg export to picture. And let's say we ran this code multiple times. Eventually we will get something like, we'll run out of space. Now with this, we can actually just use the svg clear command to just clear it every time. You might be putting this in a method, and this is automated, so you could be calling this multiple times. But using the svg clear can clear this memory. How about XML? XML is also a memory intensive one where you do the manipulations. So the DOM parse XML you put into memory, and let's say you did this DOM find XML, and you ran this multiple times. You can get something where 40 is just hanged, and you don't understand why. To mitigate this one, all you need to do is just use the DOM close XML. So how about lists? Let's say that you create a list, and you append to the list, and you think the best practice would be to clear the variable, because pretty much it looks like you're just taking that list and you're clearing it. But unfortunately, when you actually clear the variable, you're only clearing the reference. You're not clearing the location that you were actually storing, you're clearing the reference. So when you do clear the reference, 40 will stop, will hang. So the best practice for this would be to check if there's a list, and with that reference we can use the command clear list to clear the actual memory. And how about when we use selections? For instance, we use the copy name selection, and the And once we use the name selection, we're still allocating that memory. What you should do is you should clear the name selection. If you did this and you ran this, you get a big memory allocation. Now let's say that you used the cut name selection. You don't need to use the clear name selection for that, as it does its memory collection on that. So in conclusion to this presentation, the defensive program was to give you an idea to reduce some errors and crashes, to promote better, improved code, to be proactively defensive, and to be just conscientious to your code. This is kind of a hard one to what I'm trying to say is like you can't figure out every scenario for this. The point of this session was to give you a tool, something to think about when you are coding, because a lot of times you'll just take your code and you'll just assume that it's just going to work, and you take these guidelines and see if this will help you, and just mitigate. It's not 100%, but it's just to give you that state of mind. So if you have any questions and answers, there's going to be a mic going around, and we can go from there.
All right, so what's the guideline on when we can use on-air call to trap runtime errors and when it just doesn't work? Because it seems like more and more you can have an on-air call and you get a runtime error anyway.
Runtime error. That's a good question. I might have to get back to you on that one, okay. Because the runtime, the on-air call is supposed to trap every single one. I've came into some scenarios where the runtime error, based on documentation, should have been caught. And one example I had is when I shut down 40 server. 40 server is supposed to detect something if I put a runtime error in a certain code and it didn't run through there. So I've seen some scenarios with that, but I could get back to you on that one. See from that.
Okay, there are a lot of things that are automatically cleared up when a process dies. Maybe I just haven't read the documentation recently. Do you know of any documentation or anything that tells you what is cleaned up? Like, is a set cleaned up? Is a name selection cleaned up when a process dies? And so if you never use the clear but your process goes away, is it automatically cleared or does it still hang around?
It still hangs around. For me checking that, I would have to go to that Runtime Explorer and go and look at that list, that whole drop down of all the variables that are still there and all the memory. If we have any virtual memory filled up or any variables, there's a list. But that would be a good tool to think about to put on.
As I recall, when you do a divide by 0, you get an infinity value, INF.
Yeah.
And so I've tried to say if result equals INF, but I can't seem to find a way to detect that infinity has been calculated. I've tried it as a text string, and I've tried it as a numerical, and I'm just curious if there's some secret to detecting infinity.
I would have to get back to you on that one. I would probably have to do some tests. Let me get your contact later today, and something to think about on that one.
A lot of calculation.
Yeah.
And that is an error, and so generally I'm testing the denominator to see if it's 0 before I do the calculation, but I would love to be able to have a test for if the answer is infinity, then.
Okay.
Yeah.
Are you doing like floating calculations too, or floating point calculations? Like to really big significant numbers?
Yeah, yeah.
Okay.
I can, it depends. I write optimization programs that handle large arrays, and yeah, I do a lot of calculation.
And is this upgraded database from a previous old version, like 2003 or?
No,
Okay.
no, I mean, well, right now it's in version 14.
Okay.
So I'm going to be moving up, but it's just a problem that I keep running into, and I mean, I do defensively go around it. Whenever I do a division, I'm looking for the denominator to see what it's going to be, but I'd love to be able to detect infinity.
Okay. I'm gonna look into that. Right over here. Okay.
An answer to the divide by 0 is if you take the string of it, it returns INF, and you can compare that to INF.
Okay.
So you can detect a string? Because I've tried that too, and it doesn't seem to work. You know, putting INF in quotes.
Just tested it.
Okay, good. What version?
17.
Okay.
Okay, that might be a tech tip, so we'll see. We'll put that. Guys have any other questions? Here's my email address if you have any questions on this session.